Alright, so this is going to be just a video of me going over the Chapter 3 review. I'll probably split this up into a couple videos. Alright, so for number 1, use the following information to graph the function f over the closed interval from -5 to 6. So first thing, the graph of f is made of closed line segments joined end to end. So I believe that's just saying that it's continuous. Second thing is that the graph has to start at the point -5, 1. So I'm going to start with that fact right there. So -5, 1 would be like right here. So it has to start there. The derivative of f is the step function of the figure shown below. So over this, I'm going to draw, I guess I'll draw down here. So 1, 2, 3, 4, 5, 1. Okay, so here's where the graph is starting at. Since this right here is the derivative of f, that means that from -5 to -3, the slope is 2. So that means this graph has to have a slope of 2. So it has to go up 2 over 1. So its next point will be right about here. And then it has to go up 2 and over 1 again. So maybe like right there. So, okay, so there's our first line segment. So if we went over 2 and we went up 4, that would make this point -3, 5. Okay, the next part of this, so it has to be continuous, so it has to go down from there or up from there, but it has a slope of -1, so that means that next point should have to be, so if we go down 1 over 1, down 1 over 1, that should make it maybe like right here, because that's 3 spaces to the right. That's over 3 as well, so that's going to be to the right 3 and down 3, and that makes this point right here 0, 2. Okay, the next part of our graph has to have a slope of +1, because that's what the derivative function is, and so that goes 3 steps again, so it's going to be over 3 and up 3, so that would be just right here, I believe. So about right there. Okay, that would make that the point 3, 5. And then the next part of our graph has to have a slope of -2. So that's just going to be, it should be just some kind of symmetrical, except this one has to go to 6. So 1, 2, 3, 4, 5, 6. So that means I'm going to go down 2 over 1, and then I'm going to go down 2 over 1, then I'm going to go down 2 and over 1, which would put it right here at the point 6, -1. Alright, and there is the graph of f. So I think we covered everything. Closed line segments, the graph starts at -5, 1, and the derivative, so the slope of this graph is shown here. Okay. Okay, for number 2, the graph of the function is given on the same xy plane. Graph its derivative. So we're graphing the derivative this time, given the function. So I'm going to point out some important parts. So right here, this has a slope of 0. Here, the function has a slope of 0. That's where horizontal tangents are. And I would say probably somewhere around here. The graph seems to be quite this angle, since it is a 1-to-1 ratio graph. I would say that the graph here does appear to have a 45-degree angle, which would mean if this is about a 45-degree angle and this image that we have is 1-to-1, 1-to-1 ratio, that would mean that the slope would be 1-to-1 if that's a 45-degree angle. So I would say somewhere in here the slope is equal to 1, and then somewhere in here the slope is equal to -1. So if I were to graph that, the that would mean that the output of the derivative would be 0 here. It would be about 1 somewhere in here. It would be 0 here and negative 1 somewhere around here. So it kind of looks like it's making a trigonomic, maybe sine or cosine-ish type wave, something like that. So something like that should be good. Okay, for the next one, if the function is not differentiable at the given value of x, tell whether the problem is a corner, cusp, vertical tangent, or discontinuity. You can use graphing on these ones if you'd like. So for 3, I can already tell right here that it has a discontinuity at x equals 5. Okay, so yeah, I would just say discontinuity. I believe it's an infinite discontinuity. Okay, for 4, well, it is a cube root, but with an absolute value. So that should be similar to, it should behave kind of similar to a cube root of something like x squared, which is the same thing as x to the 3/2 power, which would mean that it would have a cusp. I believe I'm right in that assumption, but again, you can check in your graphing calculator. Let me go ahead and pull that up right here. So if we go to y equals, let me see what the problem was again. So we are doing the cube root. So if you go to math, option number 4, you can see we have a cube root. Go back to math, and then go over to the NUM number, and then the first option is absolute value. So we have cube root absolute value of x plus 8. Okay. And then let me adjust my window. Actually, let me do this. Just do standard. Okay, yeah, that does appear to be a cusp right there at x equals negative 8. So this is a translation to the left 8, so which is why at negative 8 it would have the cusp, because the cube root of the absolute value of x would have a cusp at x equals 0, but since it's moved to the left 8, it would be at negative 8. And again, this would behave similar to this function up here. So yeah, that would be a cusp for that one. Again, make sure you're familiar with a corner as well as vertical tangents. So corners happen a lot with absolute values or with like piecewise functions. Vertical tangents will happen with x cubes. They'll happen with x cubes, x to the 5th, x to the 7th, so on and so forth if it's an odd degree. Okay. Determine the values of x which the function is differentiable. So this is a linear function, and a linear function has no point in it which it is not differentiable. There's no corners, there's no cusps, there's no vertical tangents, there's no discontinuities, so therefore it would be differentiable for all real values of x. For 6, this is a rational function, and if it's a rational function, check the denominator to see if its factors ever equal 0. So x minus 8 and x plus 8 would be the factors here, and they would be equal to 0 when x is equal to plus or minus 8. Okay, so the denominator can equal 0 at those values. So I would say at B for number 6. Okay. 7. The figure shows the graph of a function f which has vertical tangents at x equals 4. So it has a vertical tangent here, has a horizontal tangent here. So this means that the slope is undefined. And this means that the slope is 0. Which of the following statements is false? Watch out for that word, false. f is not differentiable at x equals 2 because the graph has a because the graph so at x equals 2 because the graph has a jump discontinuity. This is a true statement, and we're looking for one that is false. So that's true. It's not differentiable there. B, f is not differentiable at x equals 4 because the graph of f has a vertical tangent. That is true. It is not differentiable here because it has a slope is undefined. So, yeah, not differentiable. C, f is not differentiable at x equals 5 because the graph has a horizontal tangent. All right, so that's probably the false one right there, because it is differentiable at x equals 5. It is differentiable, not differentiable, because just because the slope is 0, well, that still means that it's differentiable. It means that the slope can be found. The slope is 0. That's not the same thing as the slope being undefined. Let's just check D just to make sure. F is not differentiable at x equals 7 because it has a removable discontinuity. So, okay, that's true. So, yeah, C would be the false answer here. Which of the following statements, if true, cannot be used to conclude that f of 0 exists? So, assuming all these are true, which of the following statements, if true, cannot be used? Okay, so A, the limit as x approaches 0 of f of x exists. So here, remember what the definition of a limit was. So the limit says that what's happening at and what is so a limit is what's happening near, not what's happening at. So the limit as x approaches 0, let's say, I'm just going to jump over this graph right here just to kind of illustrate it. So say that we have a graph that goes right here and has a hole right here, so a discontinuity, and then it goes like this right here, or something to that effect. This would mean that the limit exists at 0. So the limit as x approaches 0 of this function f of x would be equal to 4. It doesn't have to be defined at 4. So going back to the question, which of the following statements, if true, cannot be used to conclude that f of 0 exists? So I think it's just going to be A right here, because we don't know for sure if f of 0 exists from this statement right here. We know that the limit exists, but we don't know if the function exists right here. So the function could be defined somewhere else or not defined at all. So if it's not defined at all, the limit can still exist. So let's read the other options and make sure. F is continuous at x equals 0. So if f is continuous at x equals 0, that means, so this means that what's happening at and what's happening near are equivalent. So B could be used to verify that f of 0 exists. Differentiable, well, differentiable, if something's differentiable at a point, then it is also continuous. There's a theorem on that. So that would lead us back to here, which would be true. We could use that. The graph of f has a y-intercept. So if it has a y-intercept, that means f of 0 exists. So all these three things mean that we can use to show that f of 0 exists, but not A. So I would say A for this one. Okay, let's see. Let f be the function defined below. Which of the following statements is true? So it's a piecewise function. I'm just trying to piece together what it would look like. So x squared minus 20. So that would look like, for x is less than 5, so 5's over here. Yeah, that would look something like this right here. If you plug 5 in, you would get 25. So you'd get 5. So that would have to go up to here, open circle. And then for this function right here, that would look like an upside down parabola. If you plug 5 in right there, you get negative 25 plus 20, which would be negative 5. So it would look like this right here, but at -5 right here, open circle, this is where it'd pick up. So it would look like something like this right here, but we don't need that part. Okay. A, f is not differentiable at x equals 5 because it is not continuous at x equals 5. That's true. Which of the following statements is true? Yeah. So I would say it's A, just based off of that first one. Let's make sure we read the rest of this. F is not differentiable at x equals 5 because the graph of f has a sharp corner. That's not true. There's no corner there. F is not differentiable at x equals 5 because the graph has a vertical tangent at x equals 5. That's also not true. It's a jump discontinuity right there. F is not differentiable at x equals 5 because f is not defined at 5. That's also not true. We are defined at 5 right here. So yeah, it's going to be A. It's not continuous, so therefore it's not differentiable. Alright, for 10, the function v equals s cubed describes the volume of a cube in cubic inches, whose length, width, and height each measure s inches. Find the instantaneous, that means derivative, rate of change of the volume with respect to s when s is equal to 7. So let's find v prime. V prime would be equal to 3s squared. And then we want to find v prime of 7, which would be 3 times 7 squared, which would be 3 times by 49, which would be equal to 147. And then the units on that would be inches cubed per inch, because we are comparing the rate in which the volume is changing. Describes the volume of the cube. Find the instantaneous rate of change of the volume. So we're trying to find the rate at which the volume is changing with respect to one of its sides. So volume is measured in inches cubed, and the side is measured in inches. So that would be that right there. And my app just crashed. Okay. All right. There you go. The profit in dollars from sales of X thousand compact disc players is P of X. So there's the profit of compact disc players. Find the marginal profit. Marginal profit would be P prime of X. That'd be the derivative of our profit when X is equal to 4. So P prime of X would be equal to 3x squared minus 6x plus 5. And P prime of 4 would be equal to 3 times by 4 squared minus 6 times by 4 plus 5. That would be equal to 3 times by 16 minus 24 plus 5. 3 times by 16 is 48 minus 24 plus 5. So 24, and that's going to be 24 minus 4 plus 5. That's going to be equal to 29. $29. So that's the change in cost when the units is equal to 4. All right. For 12, the figure shows the velocity of a body moving along a coordinate line as a function of time t. Use the figure to answer the questions. So in this case right here, so this is a velocity curve. It's not a position curve. So this describes the velocity of this body in motion moving along a coordinate line. It is not giving its position. Make sure you are familiar with any part of this problem. You know that the slope of this curve is acceleration. You know that whenever you're below the x-axis, this is the particle or the body is moving backwards, and above the x-axis, velocity is positive. That means it's moving forward. Okay. Speed. Speed is the absolute value of velocity. Make sure you know all these things. So when is the body's acceleration equal to 0? So since acceleration is equal to v prime, which is equal to the slope of the graph v, so that's so if you're asking for when the acceleration is equal to 0, that's when the slope of this graph is equal to 0. So that'd be here to here. So that's when you can write it as a inequality if you want. You can write it as an interval. So you could write it, let's say 2 to 3, and it looks like it's 5 to 6 seconds. Okay, what is the body's greatest velocity? Since this graph is velocity, that would be right here. This is the maximum output of the graph. And so I'm guessing that's just going to be 5. So I'd say 5 feet per second is the greatest velocity of the over this interval. When does the body reverse direction? So if velocity is negative, so right here, it's moving backwards. Velocity is positive, it's moving forward. So it changes direction at t equals 4 seconds. So in this case right here at t equals 7, I wouldn't say it reverses direction. So it's moving forward. So right here, it's moving forward. So like specifically like right here, it's moving 1 feet per second in the positive direction. Right here, it's moving 2 feet per second in the positive direction, 2 feet per second, 2 feet per second, 2 feet per second. Then it goes to -1, or so, sorry, it moves 1 feet per second, but still moving in the positive. So here, it speeds up to 2 feet per second, then it slows down to 1 feet per second, and down to 0. So it's probably stopped right here. So looks like it's moving forward, moving forward, moving forward, moving forward, and stops, but then continues moving forward. So this is not a moment of changing direction. So all of this right here, this portion, since velocity is positive, it's moving forward. So the body is moving backwards here, or maybe you can just call it in the negative direction. So moving in the negative direction. Okay, so this is also speeding up right here. It's speeding up because velocity keeps, the speed is gaining. So here, you can say the velocity is -1 feet per second, then -2 feet per second. Well, the speed is the absolute value of velocity, so it's going 1 feet per second, then 2 feet per second. So it speeds up, then it maintains speed at 2 feet per second, and then it decreases its speed because we're going down here. So the outputs are decreasing there. So it moves down, okay, and now it turns. Now it's changing direction. And then it speeds up because now it's increasing its speed again, maintains speed, decreases speed, stops, and then continues moving forward and increases its speed all the way up to this point when it's 5 feet per second. Okay, so that should describe the motion of the body. Okay, alright, find dy dx. So y prime is equal to derivative of the constant is 0. Drop the 3 down, so -9 times by 3 is -27x squared. Okay, y prime here, y prime would be equal to, drop the 4 times the 1/2 is going to be 2, decrease the power 1, so we get 2x cubed. Drop the 3 down, a third times by -1/3 is going to be just -1, so we get -x squared. So there's the derivative there. Find the horizontal tangents of the curve. Alright, so to find horizontal tangents, y prime is equal to 0. So y prime in this case would be equal to 4x cubed minus 36x. Okay, and we want to set that equal to 0. We can factor this. We can take out a 4x. We'd be left with x squared minus 9. Factor that again. We get 4x, x plus 3, and x minus 3. So we have horizontal tangents. I'm going to move this down over here. So horizontal tangents occur when x is equal to 0, x is equal to -3, and x is equal to +3. So you can leave it right there. It's just asking, I believe it's just asking for the time. So find the horizontal tangents of the curve. If you want to find the specific coordinate points, just plug them into the function, but you can leave it right there. Use the product rule or quotient rule to find dy dx. Alright, so this one's going to need the product rule. So 3x plus 5, 3x plus 5 plus 5. So you can do the first times the derivative of the second, which would be 3, plus the derivative of the first, which would be 3 times the derivative of the second, which would be 3x plus 5. So that's just going to be equal to 9x plus 15 plus 9x plus 15. So that's going to be equal to 18x plus 30. Okay, for 17, y prime would be equal to, so the first times the derivative of the second plus the derivative of the first times by the second. There's a product rule. Distribute that, you get 8x minus 8 plus 8x plus 2. So you'll get 16x minus 6 as your derivative. 18, so you'll need the quotient rule. Y prime is equal to low d high minus high d low, square the bottom, away you go, squared. Okay, just simplify the numerator, so distribute that 2x, so you get 6x minus 8x, 4x squared. Then you get plus 2x squared, all divided by 3 minus 2x squared. If you simplify that numerator, what you get, negative 2x squared plus 6x divided by 3 minus 2x squared. And I don't think you can simplify that. You could try and take out a 2x from both these terms, but I don't think that will help us simplify the numerator at all. So I think I would just leave it there. Alright, so y prime. So you got low d high, the derivative of the top, it's 3 minus high times the derivative of the bottom, which would be 18x. And then square the bottom. So 9x squared plus 7 squared. So y prime will be equal to 27x squared plus 21. Then that's going to be, you have to distribute the negative, and you have to distribute the 18x. So 18 times by 3, I want to say that's something like 54. Let me double check. Yeah, that's 54. So minus 54x squared. And then that would be plus, because you have to distribute the negative here and the positive 18. So 18 times by 7 is 126. So plus 126x all over 9x squared plus 7 squared. So that would be equal to, so that's just going to be negative 27 right there. So you got negative 27x squared plus 126x and then plus 21 all over 9x squared plus 7 squared. And there you go. Alright, suppose u and v are differentiable functions of x. Use the given values of the functions and their derivatives to find the value of the indicated derivative. So we don't know the actual definition of u or v. We just know some outputs of their functions and their derivatives. But since they are functions of x, then we'll just take the derivative. So you'd use the product rule. So the first times the derivative of the second plus the derivative of the first times by the second. Okay, so then at x equals 1, so u at 1 is 3. V prime at 1 is negative 4. Plus u prime at 1 is negative 7. And v at 1 is 6. So we got negative 12 minus, what is that, 30, 6 times 6, 42. So negative 12 over 2, so that's going to be equal to negative 54. Okay, so same thing here, except we're going to use the quotient rule. So we have low d high minus high d low and u squared, and at x equals 1. So we have u at 1, which is 4, v prime at 1, which is negative 3, minus v at 1, which is 7, u prime at 1, which is negative 6, all over 4 squared. So it's going to be equal to negative 12 plus 42 over 16. And then, so that's going to be equal to 42, isn't that 30? So 30 over 16. And then that's divisible both by 2, so that's going to be 15 over 8. Okay. Alright, so 22, find the slope of the line tangent to the curve. So I don't think it's asking us to find a tangent, it just wants, we're just finding the derivative at x equals 1. That's all we're doing. So y prime would be equal to, that's going to be 0, and the derivative of this term would be negative 12x. So at x equals 1, so m is going to be equal to negative 12, okay? Find an equation for the line tangent to the curve. So now we're actually finding the equation. So equation of a line tangent, you need m, you need x1, and you need y1. So we have x1, y1, so if I plug 1 into the function, so y of 1, that's going to give me 1 minus 6, which would be negative 5 over 3. So that should be my y, okay? Now we need to find m. To find m, we're going to need the derivative, so y prime, and we're going to use the quotient rule. So low d high, so that would be 3x squared minus high d low, and square the bottom. So that's going to be equal to 9x squared. So that's going to be equal to 9x cubed. You know what? We don't... Yeah, sure, why not? That's going to be minus 3x cubed plus 18. And then that's going to be equal to 6x cubed plus 18 over 9x squared. And if we plug 1 in, because we're trying to find the slope, and that's going to be equal to 6 plus 18 over 9. 6 plus 18 is going to be 24 over 9. Oof, that is not very friendly, but that's okay. We can do y minus y1, which would be plus 5 over 3, equal to m, which was 24 ninths. Then we have x minus 1. I think that's good. You could probably simplify the slope. That's probably something we should have done. So divide by 3. So 24 divided by 3 is 8. So we get 8 over 3. So how about we just change that at the very least. So we'll call this 8 over 3. And there you go. You can leave it right there. Find the derivative. So y prime will be equal to 4x plus 11 minus 12x to the negative 4 for that one. Okay, easy enough. For 25, 25 is a difficult one. We'll have to use the quotient rule. So we have low d high and the square root of this, so, or the derivative of this. This is just going to be 0. So the d dx of the square root of x, I'm going to write it as x to the 1/2 really quickly. That's going to be equal to 1 over 2 x to the negative 1/2, which is equal to 1 over 2x to the positive 1/2, which is equal to 1 over 2 square root of x. So that's what I'm going to write here, square root of x. So I have low d high minus high d low, and again the derivative is just going to be 1 over 2 square root of x. Okay, square the bottom, square root of x plus 3 squared. So to simplify this, I'm going to multiply this to both terms, which means it just means both of these are going to have this that denominator right there. So we have square root of x divided by 2 square root of x plus 3 over 2 square root of x minus, same thing here when I distribute this, since this is in the numerator, this is in the numerator, and this only has the denominator, except for that one being 1. That's just going to be the denominator for both of those. So that's going to be minus square root of x over 2 square root of x plus 3 over 2 square root of x. All divided by that, but I'm just going to simplify this right here. It's going to cancel with this right here, and then you're going to get 6 over 2 square root of x, because you can add these two together. 3 plus 3 would be 6, divided by square root of x plus 3 squared divided by 1, which would be equal to, that's going to be equal to 3. So 3 over square root of x times by 1 over square root of x plus 3 squared, which is equal to 3 over square root of x times by square root of x plus 3 squared. Okay, and that's probably all you need to do there. For 26, find the fourth derivative of the function. So y prime would be equal to, that's going to be 10x to the fourth minus 12x minus 4. Y double prime would be equal to 40x cubed minus 12. Y triple prime would be equal to 120x squared, and y 4 prime, so that's going to be equal to 240x. Alright, this one here, I wouldn't use the quotient rule, although you could. I would just say that this is equal to 11 cosecant of x, and so y prime would be equal to negative 11 cosecant of x times by cotangent of x, since that's the derivative of cosecant x. Y, for 28, y is equal to sine x over 2x. I would use the quotient rule here, so that's going to be low d high, which would be cosine of x, minus high d low, square the denominator, so that'd be 4x squared. That's just going to be 2x cosine of x minus 2 sine of x. There's one, you can take out a 2, you can divide out a 2, so those 2's can be gone, and that would become 2. So at the very least, you have x times cosine of x minus sine of x divided by 2x squared. Okay, for 29, I would use the product rule. So s prime would be equal to the first times by the derivative of the second plus the derivative of the first, which would be 4t cubed, times the second. So yeah, you get t to the fourth secant squared of t, sorry, that should be t, plus 4t cubed times by tangent of t. Yeah, I guess we didn't really have much, no simplifying there, nothing to do. Alright, for the next one, so we got two more. The equation gives a position, so this is the position of something moving on a coordinate line. Find the velocity, speed, acceleration, and jerk at pi thirds. Okay, so pi thirds, I'm just going to do this right now. so that I can use it as I go. So pi thirds, the angle pi thirds, this is what I would recommend anyone doing. So pi thirds is 60 degrees. So about right here, maybe we say that. And if you make a triangle, so if this is 60 degrees or pi thirds, that makes this angle right here 30 degrees. That's 90 degrees. So we have these side lengths here. 1, 2, square root of 3. Okay, and so velocity would be the derivative of negative 6 is 0, and the derivative 11 cosine t would be negative 11 sine of t. So negative 11 sine of t, because the derivative of cosine is negative sine, right? And so v of pi thirds would be equal to negative 11 sine of pi thirds, which is equal to negative 11, and sine of pi thirds would be square root of 3 over 2. So square root of 3 over 2. So square root of 3 divided by 2. So you can just say negative 11 square root of 3 over 2. Okay, so there's velocity. Okay, speed is the absolute value of negative 11 square root of 3 over 2. So it's just going to be 11 square root of 3 over 2. So there's your speed. Acceleration. Acceleration, you need to take the derivative of velocity, and the derivative of sine is cosine, so it's just going to be negative 11 cosine of t, and a of pi thirds, so the acceleration there would be negative 11 cosine of pi over 3, and so pi cosine is 1 over 2. So it's going to be equal to negative 11 times by 1/2, which is just going to be equal to negative 11 over 2. So there's the acceleration there. And jerk would be the derivative of the acceleration. And so the derivative of cosine is negative sine. So negative 11 times negative sine would be 11 sine of t. And so jerk at pi thirds would be equal to 11 sine of pi thirds, which would be equal to 11 times by square root of 3 over 2, which, yeah, just 11 square root of 3 over 2. And there you go. And last but not least, find the indicated derivative. So find y double prime. So y prime would be equal to, you need to use the product rule. So the first times by the derivative of the second plus the derivative of the first times by the second. So y double prime, you're going to have to use the, taking the derivative of this term requires the product rule again. So the first times by the derivative of the second plus the derivative of the first times by the second plus the derivative of this term, which would be 6 cosine of x. So you get negative 6x sine of x plus 12 plus 12 cosine of x, and there you go. Okay, I think that's everything for the review. I went through that pretty quickly. Hopefully that's okay. If there are any questions or if I made any mistakes, please reach out to me and let me know if you have any concerns. But good luck in your studies, and let me know if you need any help.